for number 1, we are using Hess's law, using these given reactions to manipulate them, come up with the goal reaction here. Whatever we do the given reactions, we will do to their delta H's, and that'll find us the heat of reaction for this reaction. Looking at what I want 1 hydrogen, specifically hydrogen, not H2, but just plain old hydrogen. I want it on the left of the arrow. This is the only place I have hydrogen in this form, so I want to flip it to get it on the left side of the arrow, and then also divide it by 2 to get rid of that coefficient. When I flip it and divide it by 2, I end up with that. Flipping it means change the sign. It was positive, now it's negative, and divide it by 2. That gives me the H where I want them. I want 1 Br on the left. Same thing. Here I have 2 of them on the right. Flip, divide by 2, we'll get that done. Br goes to 1/2 Br2, flip, divide by 2. That gets me the Br. I want 1 HBr on the right. Here I have HBr on the right. So I just need to divide this one by 2. Divide by 2, divide by 2, divide by 2, divide by 2. When I add all of this up, I should get my heat of reaction. I don't have to check it necessarily because I've used all of my given reactions. And on top of that, I've accounted for everything here. I could check it. I'll show that at the end. So negative 436.4 divided by 2 plus negative 192.5 divided by 2 plus negative 72.4 divided by 2. I get negative 350.65. I'm just going to call that 0.7 kJ per mole. So we're done. If you wanted to add all of these up and double check it, you totally could. It should have things cancel out to get you that reaction. So I'm going to add up everything on the left-hand side. That gives me H plus Br plus 1/2 H2 plus 1/2 Br2. Add up everything on the right side. 1/2 H2, 1/2 Br2, HBr. Things on both sides of the arrow, such as the H2s and the Br2s, since I have the same number, cancel. Cancel. What I'm left with, H plus Br makes HBr, is exactly what I wanted. Again, this step is optional as long as you've used all of the given reactions.